And the question reads here, use the definition of a derivative of first principles to determine f prime of x if a function of x is equals to 2x to the power 3. So this is the question that we have. We are given here that a function of x is equals to 2x to the power of 3. And what we are supposed to do here is we want to find the first derivative using the definition of from first principles. In other words, what they are requesting us to find is they want us to evaluate f prime of x. We know from definition, right, by basic calculus that f prime of x is equals to, obviously, the limit is h tends to 0 of a function of x plus h minus a function of x. This is all over h. Okay, now let us understand one thing here, that mathematics is always like a person that is painting. Many times when you are caught up, when you are painting, let's say this particular wall here, right? You may not see all the spots that you're missing, but what you need to do is you need to tend to come back so you reflect on whatever that you're doing, then you go back and you finish the job. What am I trying to say here? I am saying we need to not only focus on writing, but we need to also at the end of the day focus more on that which we are going to do next, or the next move. Okay, now this is what we're going to do. We are going to begin by finding f x plus h first. Okay, and we know that this is equals to 2 x plus h to the power 3. Okay, I am going to introduce you to what we refer to as Pascal's triangle, right? This is Pascal's triangle. What you do is you begin by writing the number 1, then here on the side you write 1, and you get your 2, and you write another 1. So what you see is at every row that we have, we start with the number 1 and we end up with the number 1. 1 plus 2, you get 3. 2 plus 1, the answer is 3. Okay, if you were to go on to the next row, you start with a 1, you end with a 1 again. 1 plus 3 is 4. 3 plus 3, the answer is 6. 3 plus 1, the answer is 4. These numbers that we have, they are not random numbers that we are generating. But these numbers, they are actually the coefficients, right, of binomial expansions, right, depending on the power. What am I trying to say? If you look here, 1, 2, 1, these are the binomial coefficients when we are expressing a binomial expression to a power 2, right? So we see that here, the expression here, it is to the power of 3. So if this is 1 and this is 2, and if this is 3, that means we have to look at this row here, right? So what does it mean? It simply means that 2x plus h to the power 3 is the same as, we have our 2, I'm going to use brackets. Right now we got x plus h to the power 3. So this is what you're going to do. The first here, the first coefficient is 1. So that means you're going to have x to the power 3 plus, you take here, what you have is 3, and you got your x squared h. As you move from the left to the right, you see that the powers of x, they decrease because this is the first term, and the powers of h, what do? They increase. Here the power of h was 0, and here the power of h is now 1, right? So what you got next is you got your plus, you got another 3 here. This is 3, it becomes x h squared, and the coefficient, which is the last one, it is what? It is 1. So you got your plus, it becomes x to the power 3, you close the bracket, right? So this becomes 2x to the power 3 plus, here it becomes your 6 x squared h plus what? Again 6x h squared plus what? Plus 2h to the power 3. Okay, so this is what we're going to do next, right? We are going to come in, we substitute here. F prime of x is equals to the limit as h tends to 0 of our function of x plus h. This is the expression that we have, which is what? Which is 2x to the power 3 plus 6 x squared h plus 6 x h squared plus 2h to the power 3 minus a function of x. A function of x here we are given, it is what? It is minus 2x to the power 3. And this is all over all over h. Okay, so can you see that this is 2x to the power 3 minus 2x to the power 3, it cancels. Okay, so we're going to go down with it. The answer here, it is the limit as h tends to 0. What is left here? You got here 6x squared h, right, plus what? You got here plus 6x h squared plus what? Plus 2h to the power 3. You can distribute here the h over here. You got your h again, and you got your h here, right? We are just playing with the fractions that we have here. So this is equals to the limit as h tends to 0 of here. What you're going to get? You're going to get 6x squared plus what? Plus 6x h plus what? Plus 2h h squared, right? Now, when you are coming to this point, what do? You break it, right? You split it, right? Using the laws of limits. We are not going to go into that because we are trying by all means to have the video as short as possible. So the limit as h tends to 0 of 6x squared, right? This is plus the limit is h tends to 0 of 6x h, and you got plus the limit is h tends to 0 of 2h h squared. This is equals to the limit as h tends to 0. We do not have any h here, so this becomes 6x squared. Here the answer that you get, this gives you 0, right? Because as h tends to 0, 6x h becomes 0, and this becomes 0 again. So this will be your final answer. And you can confirm that again, because if we use the rules of differentiation, you simply come and you multiply the power multiplied by the coefficient. Yeah, so 3 times 2, you get your x, then you get your x to the power 3 minus 1, and the answer that you get here is you get your 2. Thank you.